Hello everyone, I hope you're all doing well. In this brief concept talk, I'm going to consider coordinate transformation between two orthogonal frames. Okay, so as a hypothetical example, let's consider the following. Okay, so let me consider the ij coordinate frame. Your typical Cartesian coordinate frame. Let me consider to be in the direction that I have drawn here. Okay, so let me say this is little I and then little j, and then let me say that in an example, perhaps here is a set of unit vectors that I have. Okay, so this I'm going to call as some et and then some en. Okay, and let me say that the angle between the two frames is given as the angle theta. Okay, of course et and en are perpendicular to each other, so which means that this angle here is also going to be equal to theta. Okay, so I'm going to say that okay, I and j are perpendicular to each other. Okay, and then et and en are also perpendicular to each other. Okay, and it is very obvious to see that the magnitude of all of these are equal to 1. Okay, so the magnitude of et is equal to the magnitude of en is equal to the magnitude of I is equal to the magnitude of j. This is equal to 1. Okay, because these are unit vectors, right? This is a no-brainer. Okay, now what am I going to do? Let's say that I want to coordinate transform et and en into I and j. Okay, let me say that is the situation I want to do. Okay, so transform, so say we want to transform et and en to I and j. Okay, how do I do this? Okay, and what would be the use of this? The use of this would be probably that, okay, maybe I know the velocity in the et direction. How do I write it in the I and the j direction? By transforming et into I and j. Okay, so that's essentially the basic idea here. Okay, so let me do the transformation here. So let's do this step by step. So they're all orthogonal frames. Okay, so I'm going to first consider et, I and j. Okay, so first consider et to I and j. Somehow I have a preference for blue versus red in color. I don't know why. Maybe I'm just silly. Okay, so let me take the ij frame. So the frame that you want to transform to, you just draw as it is. Okay, so this is the ij frame. This is I and this is j. Okay, then I have the et, which I'm going to be drawing in this particular manner. Okay, so this is going to be et. Okay, and then the angle between the two is known to me as theta. So what do I do? From the head of this vector et, I drop perpendiculars onto the other two directions. So from the head of this vector, I drop a perpendicular on here to get the component, right? And then I get a perpendicular on here to get the component as well. Okay, so starting from the tail all the way to here is the component in the I direction, and likewise in the j direction, as you can see. And so what you can further do is this. Okay, what is the magnitude of this component? That is going to be the magnitude of et times cosine theta. What is the magnitude of that component? That's going to be the magnitude of et times sine theta. Then we know the magnitude of et is 1, which means that I can now say, okay, et is magnitude of et cosine theta in the I direction, magnitude of et sine theta in the j direction, but magnitude of et is equal to 1, which means that et is just going to be cos theta I and sine theta j. So this is the transformation of ET into I and j. Okay, so this is transformation of ET into the IJ system. Okay, that's the first thing. Then let me also do the same thing for En. Okay, all right, so let me consider that here. Okay, so then let us transform. So this we call as A, so we're going to call this as B. Okay, so En to I and j. Okay, how do we do this transformation? Idea is basically the same. Okay, the same way that I took this ET and then broke it up into components, I do the same thing for En. So I draw IJ and then En. Okay, so draw the home coordinate, which is your IJ system, right? This is what we want to convert to. That's the first thing you want to do. Okay, so this is I, and then this is J, and then I want to draw the En direction as drawn here. Okay, so this is going to be En, and I know that this angle here is the angle theta. So just not so as to not crowd this up, I'm going to bring that and write it here. Okay, fantastic. Maybe here. Okay, that's better. All right, and then so what I do is this. Okay, if I draw perpendiculars, look at this. If I draw perpendiculars from the head of En, I will find one here. But then if I draw another perpendicular from the head of En, or draw a line parallel to the y-axis on the head of En, I see that I have to extend the I-axis in the negative direction. You see that, right? Which means that the I-axis extended in the negative direction becomes equal to minus I. And then the components are going to be all the way starting from the tail here onto the point of intersection. All the way from the tail onto the point of intersection. Of course, these are right angle triangles. And so I can write the components as follows. Okay, this is going to be magnitude of En times cosine theta. And this is going to be magnitude of En times sine theta, but in the negative I direction, which means that I can say, okay, En is now minus magnitude sine theta I magnitude cos theta j, or En is equal to minus sine theta I cos theta j. This is the transformation from En to I and j. Okay, so this is the transformation from En to I and j. Okay, then maybe somebody will ask you a question. Okay, how do you transform I and j to En and Et? Okay, that's the same way as we have done. Okay, so let me maybe do that very quickly. Okay, so let's say, okay, I to Et and En. How do we do this? Now your home coordinate system is Et and En. So I'm going to draw Et and En first. Okay, so here is Et. Okay, and then here was the En direction that was given to us, approximately perpendicular to each other, right? Doesn't look too perpendicular. Maybe this is better. Okay, so this is going to be my Et. This is going to be my En, and then I draw the I coordinate direction, which was drawn here. Okay, so this is the I direction. And then I also know that this angle here is the angle theta. Then I immediately recognize, okay, hey, if I want to project I onto the En direction, I have to extend En in the negative direction. So that's precisely what I'm going to be doing. Extend it onto the negative direction. Okay, and once I'm done with that, then I'm ready to do the projections. From the head of I, drop a perpendicular. From the head of I, drop a perpendicular. Okay, these are all perpendicular lines. Okay, these are all perpendicular lines. The first thing you got to do is, okay, I have extended this, so this becomes minus en. Okay, then I start writing the components, and before that I draw the components. So one along this direction here, then one more along the negative en direction, as you can see here, and then the magnitude of these components. This is going to be the magnitude of I times sine theta. This is going to be the magnitude of I times cosine theta. But what do you know the magnitude of I to be? Is equal to 1, so which essentially tells me that I is equal to plus magnitude of I times cosine theta in the ET minus magnitude of I sine theta in the EN, or I is cos theta ET minus sine theta En. Okay, so this is the transformation from I to En and Et. From I to Et and En, and while we are at it, we might as well do the last one, which is from J to Et and En. Okay, so let me do that too to cap off everything. Okay, J to Et En. Okay, this is some arbitrary Et En. Et and En can be replaced by Er and E theta, so the same procedure can be applied, okay, to transform between any two orthogonal coordinate frames, and I'm going to write that statement down at the end. Okay, so here is my I direction and my J and En and Et directions. Okay, sorry, J directions. This should be fairly straightforward. Okay, so here is Et and En. Okay, and then here is my J direction. I'm sorry, this is J, right? And I know the angle here is theta. How do I know that angle? I go to my initial figure. You see, if this is theta, this is not that. This is theta. The other angle is also theta. Okay, all right. So I come back here, and then I say, okay, now all I have to do is draw perpendiculars. This is basic idea from statics. Okay, draw perpendiculars, get the components along these directions. Starting from the tail all the way onto there is component along the ET. From the tail all the way to that intersection, component along En. Okay, and so I just write it down now. This is a magnitude of J times sine theta. This is magnitude of J times cosine theta. Magnitude of J is just equal to 1, which means that J is equal to magnitude of J sine theta Et, magnitude of J cosine theta En, or J is sine theta Et cosine theta En. Okay, and as you can see, this is the transformation from J to Et En. Okay, and the important note that I want to make. Okay, so note: to perform any coordinate transformation, follow the same procedures outlined. Okay, so the procedure outlined above, the above procedures can be followed. Okay, to perform coordinate transformation from one orthogonal system to another. Okay, so this is a general idea. I have just taken a hypothetical example, but in general the same procedure can be followed to perform coordinate transformation from one orthogonal system to the other. So this means that, I can follow the same procedure to transform between I and j to et en. I can transform that to er e theta. All of these can be done backwards as well. I can do transformation from ij to er and e theta as well, you know. So I can do the following. I can maybe draw some nice arrows here, so I can do that too. I can directly transform from here, and then, you know, I can do any other kind of transformation that I need. Okay, so it is not necessary that I go from ij to etn and then get er and e theta. I can directly also transform from ij to er and e theta as long as the angles are known. Okay, so this can be done as long as the angles are known. Okay, as long as the angles are known. Okay, so this was a very brief idea on coordinate transformations, and you'll see that I have made use of this idea to solve a simple problem on particle kinematics in all the different coordinate frames. I hope this has been useful to all of you. All right, take care of yourselves and stay safe. Bye-bye.